Now let's work another problem where we prove a limit. Prove that the limit as x approaches negative 3 of x squared minus 9 over x plus 3 equals negative 6. Now remember, you're using the epsilon delta definition of the limit. I want you to pause the video, try this on your own, and then see how I do it. Okay, so we must show that for every epsilon, for every positive epsilon, there is a delta greater than 0, and of course it's going to have to depend on epsilon, so let me tag it with an epsilon to remind myself of that, so that 0 less than absolute value x minus the quantity negative 3, absolute value less than the delta sub epsilon, implies, in this case, absolute value of our function x squared minus 9 over x plus 3 minus negative 6 less than epsilon. Now remember, this provision that the difference in absolute value of x and the limit point here, negative 3, be positive guarantees that the x in this expression cannot be negative 3. And notice our denominator here would be 0 if x is negative 3. So that's a very useful fact. In other words, just having this difference in absolute value less than delta in our argument is not everything. This provision that it be positive is extremely important to keep in mind, because that means we can factor the numerator and cancel. So now let's carry that out and solve that inequality. Okay, so our inequality is x squared minus 9 divided by x plus 3 minus negative 6 in absolute value less than epsilon. So let's start simplifying. Let's factor the numerator here. So that's x minus 3 times the quantity x plus 3 all over x plus 3. And minus a negative 6 is the same as plus 6. Now we can cancel the x plus 3's, and we have simply x minus 3 plus 6 in absolute value less than epsilon. That's the same as saying x plus 3 in absolute value less than epsilon. But notice x plus 3 is the same as absolute value of x minus negative 3 is less than epsilon. So notice this inequality is equivalent to this, is the same as this, is the same as this, is the same as this, provided x is not equal to negative 3. Well, notice this is very simple now. Here's our limiting point, the x naught, and so we're finding absolute value of x minus x naught less than epsilon for x not equal to negative 3 is exactly the same as the inequality x squared minus 9 over x plus 3 minus negative 6, all in absolute value less than epsilon. So in this case, it's very easy. The delta sub epsilon is simply taken equal to the epsilon. Let's look at another problem where we prove a limit involving a trig function. Here we want to prove the limit as x approaches 0 of x times the quantity sine 1 over x equals 0. So remember, what we have to do is for every positive epsilon, we need to find a delta which will depend on epsilon, positive, so that 0 less than absolute x minus, in this case, 0 less than the delta sub epsilon implies absolute value of x sine 1 over x minus 0, then absolute value is less than epsilon. Notice how important this provision that this absolute value of the difference be positive is in this case, because sine 1 over x is undefined at x equals 0. So we certainly can't have x being equal to 0. Now, absolute value of x minus 0 is just absolute value of x, and likewise absolute value of this quantity minus 0 is absolute x times sine 1 over x. And so consequently, this inequality is the same as just looking at those two terms, absolute x times absolute sine 1 over x less than epsilon. Now here, let's ask ourselves, how big can sine 1 over x ever be? What do you know about the sine function? Remember, the sine function is always between -1 and 1, and so consequently this quantity right here is always less than or equal to 1. And that means this whole thing on the left is less than or equal to absolute x. I'm going to just write that, less than or equal to absolute x. Notice it's absolute x less than delta that we're looking for to imply that this quantity is less than epsilon. So if this whole thing is always less than absolute x, then all I have to do is take the delta equal to the epsilon. If I take the delta equal to the epsilon, this inequality would be the same as this, which would imply this, because that's even bigger than this. So we just take delta sub epsilon equal to epsilon. Okay, we've discussed the precise definition of a limit, and we've worked some problems with the precise definition finding deltas given epsilons, and we've proved some limits using the epsilon delta definition of a limit. Remember, when you have to do this given a specific epsilon, solve the inequality absolute f of x minus L less than epsilon first, and then find the delta.